Hey y'all, today we're going to talk about congruent triangles. We're going to look at reasons why triangles are congruent, reasons why sides and angles are congruent, and we're going to look at how to write a basic proof. So first, let's talk about some of our postulates. So if I see a triangle that looks like the first one, I can say that this side matches that side. This side matches this side, and this side matches that side. So I did not use any angles. So I would say that the triangles are congruent by the side, side, side postulate. In the next picture, I see that I have an angle congruent to another angle, a side, excuse me, I can write an S, a side congruent to another side, and a last angle congruent to a last angle. So I didn't use any of these, and I can see that I have angle, side, angle congruence. In the next picture, they put numbers, but I will not be fooled. In this picture, I see that 15 matches 15, so this is a side. 72 degrees matches 72 degrees, so this is an angle. And 20 matches 20. So I'm left with side, angle, side. All right. The next two are just as straightforward. Angle matches angle, so I can write an A. Angle matches angle, so I can write an A. And side matches side. So crossing out everything I didn't use, this looks like angle, angle, side. Okay, and I'm just going to circle those to really highlight, really drive home that point. In the next picture, I'm going to use the same techniques, right? I see an angle that matches an angle, a side that matches a side, and another side that matches another side. Oh dear. Oh no. Arnold Schwarzenegger says, don't ever use side-side angle. Unless. So I definitely see side-side angle here. However, I can see that we have the right side-side angle. So when you have the right side-side angle, this is hypotenuse leg. So don't ever use side-side angle unless it's the right side-side angle. When we see these in proofs, we're going to make some sort of statement, such as triangle ABC is similar to triangle DEF, and we'll have to choose one of these three, whichever one is the most appropriate. So for example, if you see angle, side, angle, you'd have to circle angle, side, angle. You'll know based on the statements that you make. We'll see that in a little bit. All right, so now let's look at some of these lovely angle properties that we've been learning the entire year. So first off, talking about vertical angles, right? So if they give you the reason that vertical angles are congruent, we know that we're going to be looking for these angles that meet at the vertex that are across from each other. So for example, naming this angle on the left, we can name it angle RPQ, where the angle is at P, so P had to be in the middle. And we'll say that angle RPQ is congruent to its vertical angle pair, MPL. Could I also call it angle LPM? Of course! So now we get to two properties that require parallel lines. So in this first picture, I see that AB is parallel to DC, and it has a transversal through DB. Well, I can see that inside of those triangles, once I highlight those angles, that I have a Z angle here and here. I think of them as the elbows for some reason, but you can definitely see a big Z. If we erase these extra edges, I think you'll be able to see it even more clearly. So that means that when we see alternate interior angles, we can name something like angle ABD is congruent to angle BDC. Speaking of parallel lines, I see that with corresponding angles, I have a parallel line here and here with a transversal. And again, where those angles are meeting, I'm getting those elbows, I'm getting those angles. So the angle on the left, I could just call it angle Z because it's the only angle there. But for this angle, it's WXU. because there's two different angles I could name. But I have to be vigilant because I see I could also mark VY parallel to UW, which would give me two more corresponding angles. One is at angle W, and the other would be at angle, sorry, I have to erase a little bit because I can't read myself anymore. My bad. At angle ZYV. And both these are going to be when we see those terms corresponding angles. Lastly, we have our reflexive property, this idea of what they share. So I see two triangles here. The first triangle, EFH, is stacked on top of triangle EGF. Notice that when I highlighted the two triangles, I highlighted one side twice. This side EF is present in both triangles, so I can make the statement that side EF is congruent to side FE, because that's the reflexive property. Something will always be congruent to itself. Well, let's look at that in context. So I'm going to show you the best way to go through a proof. I'm going to make your life as easy as humanly possible. Here are the key points you should look for. And you're probably already saying out loud to yourself, Miss Atkinson, you should always look at the given first. And you know, you're totally right. So whatever is given is generally going to be your first statements. So for example, I see angle GHI is congruent to angle IFG. The reason that that's true is because it's given to me. Here's the step you might be skipping. So you see how we just read a statement and wrote in its reason? So then I'm going to have to take this angle and mark it in the picture. So angle GHI means I want to place the angle at H between G and I. And I know it's congruent to angle IFG. Right? Every time you read a statement, please highlight it in the picture. It makes your life way easier. The next given, right, because I see the word given, is that GF is parallel to HI. To show that, I'm going to make sure that I can see the arrows on GF and HI. The last free point, because trust me, we want to get as many points as we can, is whatever you're trying to prove is your goal. So anything you're trying to prove should always be in the last box. So because I'm trying to prove GH congruent to IF, it has to be the last statement I make. Okay, those are our free points, and from there we're just going to work down the line. So let's mark angle FGI. Because G is in the middle, we'll put the arc between F and I at G. Two arcs this time to show that it's congruent to another. Then I'm going to mark angle HIG, right? And I'm going to ask myself, what do I call that angle pair? Part of the hint is the fact that this line is parallel to this one, and they share that transversal. That means the reason is going to be my alternate interior angles, right here. So you're fine to write the letter F, but I'm going to write out the whole world. Alternate interior angles. Remember, this will probably be a drag and drop problem, so you'll just be able to drag, if two lines are parallel, then alternate interior angles are congruent onto that box. Okay. Similarly, I almost skipped it, but this given should be here. And this GF parallel to HI should be here. Right now, so now we're trying to remind ourselves, what is the reflexive property? I know that when I think reflexive, it's something shared. So between these two between these two triangles, they share the side, they overlap at side GI. So I'm thinking something like GI is congruent to IG. Okay, which I can see as option E in my answer bank. So now that I'm trying to prove triangles congruent, whenever I see triangle congruent to triangle, I'm going to label my angles as A. This is an angle, so he's an A. And I'm going to label my side as S. So I can see that this looks like angle, angle, side, which is option B. And one thing to note, we're completely done, right? This problem is done. I know it's a 100%. I'm very confident in it. But notice how the last thing we were trying to prove was segments, right? So if this is, let's undo that. What was that? If the last thing we're trying to prove is sides or angles, which this is, so GH is a side, then I'm always going to say that the corresponding parts of congruent triangles are congruent. If you're proving triangles, you need one of the big five. If you're proving anything else, the sides or angles at the end, you need corresponding parts of congruent triangles are congruent. Okay, almost there. All right, y'all. So looking at some more examples. First, which triangle below is not congruent to the other three triangles? So what the question is really asking is, which of the three is not like the others? So to start out, we're going to circle things that are similar. So 70 matches 70, matches 70, and 60 matches 60, 50, oh no, going a little bit thinner. 50 matches 50 matches 50, and the side 9 matches this side 9, matches this side 9, matches this side 9. Well, so far I have two that kind of could look similar and then two that kind of look different. So what I really need is to get the third angle to determine which is definitely not the same. So I can see all of these triangles have 70, 60, and 50, right? Well, solving in this triangle, let's get the third angle. 70 plus 60 plus what I don't know must all add to 180 degrees. So 70 plus 60 is 130 degrees, and 130 degrees plus something must be 180 degrees. So if I subtract 133 degrees from both sides, the angle I don't know is 50 degrees. Right, so I'm going to erase that question mark and put that 50 degrees in there. Well, now I can see that anytime I have 70 and 60, I should get 50 degrees. Anytime I have 70 and 50, I should get 60 degrees. So anytime I have 60 and 50, I should get 70 degrees. So 70, 50, 60, 50, 70, 60. And remember, if you're not comfortable with that relationship, you can solve it each time. So then I highlighted in yellow my 50 degrees, so let's continue that trend. So 50, I highlighted in pink my 60 degrees, and I highlighted in green my 70 degrees. So now I can see that three of these triangles match, right? So this triangle matches this triangle matches this triangle. So then this last one, D, is the odd man out, right? Because I want to know which one does not match. Last problem, triangles A, B, E. I'm just going to highlight these so you can see them better. So A, B, E, A, D, E, and C, B, E. C, B, E are shown on the coordinate grid. And all the vertices have coordinates that are integers. I have to determine which two statements are true. Either none of them are congruent, exactly two of them congruent, or all three of them are congruent. Well, first, I'm going to try to look for shortcuts. I see that I do have an angle here. All of these angles are 90 degrees because the slopes are opposite reciprocals. But I can also focus on the sides. So looking at the side CE, I see that it's made by taking a triangle that has a bottom length of 4 and a height of 2. Similarly, if I draw a triangle from AE, It has a bottom of 4 and a length of 2. So this side must be congruent to that side. So far, so good. So then from B to C is 1, 2, 3, 4, 5 long. And from A to D is 1, 2, 3, 4, 5 long. So for that last side, I see that it's 2 by 1. And this one is 2 by 1. So they're definitely congruent. So by side angle side, right, because remember that these angles are vertical, so they must be congruent. By side angle side, I know that BCE, or CBE, must be congruent to ADE. So I have to be able to match up CBE. Oh, sorry, I'm trying to pick the right color. So I'm trying to match up CBE, which is right here, with ADE. Because this is the only option where they're both congruent, I actually know that this answer must be correct without even looking at the third triangle. Remember, you can also use the distance command in Desmos to try it a different way.